So this video is going to be a more thorough overview of installing UHD RF drivers for USRP, Open5GS, SRS RAN, GNodeB. We'll even touch on UE RAN SIM and SRS UE as well. And then we'll even get into like using a commercial UE to connect to our network. So I've got an outline of how this is going to be broken into. So installing everything, doing some admin, then configuring everything on the network, and eventually getting to running everything. So hopefully this will answer any questions that people might have about installing. I'm going to be using Ubuntu 22.04. So if I come here, we'll just be able to see everything I've got going right now. So Ubuntu 22.04. This is the preferred, installation candidate operating system, just because we can use pretty much the package manager to run everything here. And with that being said, we're going to be running everything locally on a single laptop. So we'll be running Open5GS, SRS RAN, everything on the laptop. We'll get into configuring SRS UE, but we won't run that from the same laptop, just to make things a little easier. So yeah, let's get started. The very first thing we need to do before we install any of the 5G network software is we need to install the USRP UHD drivers, and then we need to also download images for the USRP that we're going to be using. So it's simple. Pretty much you can just come to the EDIS manual page, install online instructions. And so come down to here, install on Linux using a package manager. So you can just copy this and paste that in here and install. So now that that's installed, we just need to navigate to our UHD utils directory, and then if I go in here, I will see the UHD images downloader script. So then I'm just going to run that, and that's going to start downloading all of the USRP images. So now we can see that all the images have downloaded. If we go up here and we just look at this user share UHD images, so if we see there, so share UHD images, and then we'll see everything in there. So we'll see a little bit of overlap there. Yours might not look like mine because it took me a couple times due to the network issues I'm having. So now we can move on to SRS RAN project, the 5G GNodeB. So if you come to the GitHub page, you just have to navigate down to the documentation, and then go to SRS RAN project documentation, get started, and the installation. So it'll lay it out for you. So start to finish is first we're gonna have to install dependencies. Install RF driver, we already did that, so actually we can check these off over here. So now we're on to SRS RAN project. So for the dependencies, it lays it out for you right here, so I can just copy that, bring that over to my terminal. I'm going to go to my home directory and I'm going to just paste that in here. I've already have that already installed, so really no need for me to go with the dependencies. You might not have them installed, but just make sure you get those installed at first. Then simply we just come down to the clone and build. So we're going to copy this git clone command, and I'm going to clone that into my home directory. So once that's cloned, I can run ls and I can see my SRS RAN project directory. So I can move into that, and then it's going to ask me to make a build directory, and then I'm going to move into that directory. And if we go back to the documentation, so I just knocked out those two, and now I'm just going to run cmake. So cmake / So we ran that, and now we're going to run the following make command. And this one generally takes a little bit of time to get through, so yeah, you'll see it start building, and yeah, just wait here. Takes roughly 5 to 10 minutes depending on your connection. So we're wrapping up the make next. So that'll be finishing here any minute now. So the next step in the clone and build process is optional, but I definitely recommend running the make test. Again, it runs through a few thousand tests just to make sure that everything was built properly. And then once it runs through those tests, we will do the sudo make install, and SRS RAN project GNodeB will be installed on our computer. So yeah, 4,642 different tests. It generally runs through this pretty quickly. Some tests take a little bit longer, and then it will give us our results at the end. So all the tests have run. It gives us a summary of the test time and all the different tests that were run. And if we go up a little bit, we can see 100% tests pass. So that's good. That's what we want to see. And then from there, we just run our sudo make install. Now once that's done, that's pretty much it for the install of the SRS RAN GNodeB. We'll get into configuring it a little bit later. Next is the little bit more complicated process of installing Open5GS. So if we go again to the GitHub page, we go to Open5GS, scroll down, and there will be a documentation link. So we'll follow that and go to Quick Start. It gives you a bunch of overview of the entire architecture of the system. When you do install Open5GS, it will install the LTE network functions as well. We're going to end up just disabling those and just running the pure 5G network functions that are needed for just 5G network access. So if we scroll down, the first thing that's going to pop up is getting MongoDB. So we see that over here as kind of the steps. We install MongoDB, then Open5GS, and then Node.js for the web UI, which is used for subscriber management. So we're just going to start following some of these procedures here. Run this next. It's already installed for me, and then some of this is probably already going to be installed as well, but just for redundancy's sake, I'm going to redo it. This next portion, depending on the distribution you're running, you might have to change. Obviously, I'm running 22.04, so I'm installing Ubuntu Jammy, or setting up for Ubuntu Jammy. If you're running 20.04, then you would change that to Ubuntu_focal. I don't know if there's an underscore in there or not. but it looks like there is not. So yep, just run that. So we're good there. Run another sudo apt update. And I probably already have Mongo installed. Yep. And then again, my Mongo is already running and enabled at boot. But for the next steps, you would run the sudo systemctl start Mongo to start, and then enable Mongo D to have it start at boot. And then, so that's Mongo. So we're getting there. Next step is to add the repository for Open5GS. Again, I probably already have this set on this computer. But it would prompt you if you want to enter. Yes, so I'm just going to hit enter here. It is now adding that. And then we would do another sudo apt update so that it queries that repository. And then we're just going to install Open5GS. And this is going to install the configurations in your etc / Open5GS will be the directory that we're going to go into for changing the configurations for all the network functions that are being installed right now. So it's pretty simple. There's all your network functions. Again, some of those are LTE, some of them are 5G. I believe, yep, it will start running everything immediately. I think I've already disabled the LTE processes, but we'll go into doing that. So we have Open5GS installed, so the last thing that we need to do is install the web UI. So some of this is redundant. And I already have some of this installed. Forward, and lastly here, I'm just going to overwrite what I already have. Next is we're going to run these commands. Basically, if you just go through it step by step, you shouldn't have any problems. Again, some of this is being done redundantly on this machine. So we might see some issues. So yeah, it's already installed. So what should happen is if I come here, yep, so I already have it installed, but you have to have Open5GS running in order to access the subscriber database. We'll get into configuring that a little bit later. But that's it for Open5GS install. As I mentioned, when you install Open5GS, it will install the LTE network functions. So I went ahead and just kind of recreated that. So I just started. These are the 5 LTE network services that that will be running. So it's pretty simple as just to disable and then stop those services. So just one by one going through and killing them. So now if I go look, now there's no processes running. Just stopping them will just stop them, but if you don't disable, do a sudo systemctl disable open5gs dash whatever the LTE network process is, those network functions will start on boot. So just be aware of that. And just to make things easy for myself when starting and stopping, because I like to analyze logs and break it down in between starting and stopping open5gs, and also when you change configurations, you need to restart the entire all the network functions, especially the ones that have been made changes to. So generally what I like to do is go to my user bin and do a sudo touch 5gc. So this will be used to start the 5G core, and then a stop. And you can name this whatever you guys want to, but generally I'm just going to go in and edit each of these files. I'm going to show you, I already have my script pre-made, so I'm using ZSH, so my shebang is going to be pointing to my interpreter, which is ZSH. I'm going to remove the logs every time that I start 5GS, because I want to start fresh every time, and then I'm just going to be starting each of the 5G core processes. So as simple as that on the start script. And you guys can obviously use whatever editor you're comfortable with. I just like to use Vim. So now I'm just doing the same for the stop script, and all we're doing is just stopping. There's nothing else going on there. So there's that. Quit there, and then now I just have to run a chmod plus x on both those to make them executable. So now I can start 5G core by just typing in 5gc. That'll run. If I do a psaux now, I will see everything is up and running for the 5G side. Now if I run stop 5gc, there. So pretty simple, straightforward there. Just makes your life a little bit easier. So now with open5gs, right now it's currently not running. So there's just a few kind of things that you need to do up front, depending on what your use case is. In this case, I want to use open5gs and my SRS RAN GNodeB to provide data to my handset, my COTS UE handset. So utilizing the internet connection that I have, it will provide data to my handset. So there's a few things that we need to do there. I'm just going to change, and this isn't really necessary to change into the open5gs directory, but I'm just going to do it anyway. So the first thing we're going to do is we're going to set up our OGS ton. So I'm going to come here and just run an IF config. And I will see that, so there is OGS ton. When I installed open5gs, it more than likely created that tunnel. But if you don't see that in there, then you just need to run these 3 commands to assign it the IP address scheme that it's going to give the handset or the device that you're using, and then set that IP link OGS ton to up. So right now we're at the scenario 2 here, where the interface is up, but there's no IP address configured with it. So we just need to run this sudo IP adder add to that device. So I'm just going to copy that now. And now if I run if config, we see right here that we're good there. Next is we need to ensure that IP forwarding is enabled, so I can check that by running the sudo sysctl-a and then grep that with IP_forward to see what the current status is. So I see this is what I'm looking for right here. So net IP forward equals 0. I want that to equal 1. So if net IPv4 forward equals 0, then run sudo sysctl -w net IPv forward equals 1. And if I go back and run that, now we see that we are set to 1. And then next is we need to set our IP tables to be able to forward traffic from the internet through our OGS-TON interface. So I can check what I currently have. And then what we're looking for is we should see that OGS-TON with a masquerade on it. So again, if that's not displayed, this is what we should be seeing, but we just have to run this sudo IP tables command. So again, just copy and paste that. If I go back and check my rules now, there it is. So now we have it set up, everything on the back end to provide data services to our user equipment. Now we get into actually configuring our network to operate with SRS RAN GNodeB. So if I go and look at my etc Open5GS, I'm looking at all of the different config files for the 5G core. So I'm going to first look at the amf.yaml and open that. And by default, logging is commented out and it's set to info level. If you want to go ahead and change that to anything else, I generally like to run debug or trace just when I'm analyzing different network functions working with each other. Next is going to be, so since we're running Open5GS and SRS RAN on the same laptop, we can pretty much just keep all of the default networking set. We'll get into changing the GNodeB IP address so that it doesn't conflict with any of the loopback addresses that are being run. And two, when you install Open5GS fresh, the PLMNs, so in these three different areas that we see, 1, 2, 3, will be set to not default, to not 00101. That's what I'm running my commercial off-the-shelf UE and then all my other UE simulators on using that PLMN, and that also just needs to make sure that it matches with your GNodeB. And the tracking area code needs to match with your GNodeB. I just like to use 77 for that case. But yeah, just make sure that you change your PLMNs to whatever your SIM cards support or whatever programs you're using support. Your TAC changes to match your GNodeB. You can change some timer values in here if you'd like, but generally don't touch that. Another thing, if you're looking to change any of the reject codes, you basically just need to uncomment from here down to this. So uncomment all, or remove all the hashtags that are in that place, and then you can change the reject codes appropriately there. The other two configuration files we're going to look at is the SMF and UPF. Those are really the three major ones that you're going to possibly configure depending on your how you have everything set up. But again, if I go in here, logging's commented out, and then by default it's just set to info. I'm going to change that to debug. So if we go down here, again, our .4 is going to be our SMF address. So the PFCP server address is going to be between the SMF and the UPF. So if those are on different machines or not being run locally, then you'll just have to adjust those accordingly. And then making sure that the GTPC isn't used unless you're running the LTE, but GTPU is used. So again, just making sure that everything's set appropriately here. You can change your DNS configuration if you'd like to use a different DNS server. By default, it just uses the 8.8.8.8 or 8.8.4.4. So we'll be able to analyze that when our user equipment is doing a DNS request for a web page that you might be wanting to access. So next we'll look at the UPF. Similar here, just changing the log level. The UPF isn't on the service-based interface, so you'll typically see differences in some of the logging with the UPF as opposed to the rest of the network. But we just here we see our UPF PFCP address. So again, the .7 is associated with the UPF, and then also its own GTPU server address .7. Again, these might need to be changed depending on your configuration, but running everything locally, you shouldn't have any issues. Next, we're going to look at the web UI. So again, we need to start our 5G core in order to access the web UI. If I go to, again, localhost 9999, you will be prompted to log in. The default username is admin and the password is 1423. You can change that if you'd like, but generally it's going to bring you to this page here. So I can go ahead and hit add a subscriber. So I've got all my information for my configured SIMs here. I've got a bunch of different IMSIs, but so I can just basically copy and paste those in. The keys, so the K and the OPC are really the ones that are more difficult to input if you don't have them off the top of your head. So I'm just going to put those in, and then you need to confirm what is set on your SIM card. So if you go on your phone and go to your network settings and go to APN, you can configure all this, but generally I change mine to APN, and then we need to set this type to IPv4. And then I also add an IMS, so I have another PDU session for IMS that is also using IPv4. You generally don't have to change anything else with the slice configuration unless you're doing some network slicing. But if we go ahead and we save that now, we click on it, we can see, the key, the OPC. We don't need to change the AMF. And then we just see our DNN APNs that are configured for IPv4 and the different quality of service indicators and identifiers that are associated with those PDU sessions. And you can add multiple other handsets or IMSIs as well. So I generally have 4 or 5 different SIM cards that I'm using that I will end up inputting in here. Now we get into configuring our GNodeB. So from our home directory, we know that we can go to our SRS RAN project directory and then configs. By default, it's going to provide you with all these different configuration files that are kind of pre-canned configuration files. I have my own configuration files too. So if you go to my GitHub page, go to 5G network, go to my SRS RAN project. And then so for sake of using this with SRS UE, I'm just going to go to my GNodeB for band N3, go to my raw, and then I'm just going to copy that, and then I'm just going to run wget. Oh, that's no fun. So my bad. Wget that. So now I go in here and I should see my GNodeB N3 config. So we'll go in and we will edit that config file. Again, you can use this with SRS RAN UE, but you can also use it with commercial devices that are capable of that. So you see, if you pull my configuration off, don't worry about the notes at the top, but this was configured for my VPN that I was using. So go ahead and change the AMF address to the AMF, so the .5, and then the bind address is going to be the loopback address assigned to the GNodeB when it goes and connects to the 5G network. So basically just want to use anything that is not being utilized. So generally I use 66. Setting your SDR configuration, depending on if your USRP has a GPSDO module installed in it, then you might use that as your clock and sync source, but otherwise if you're using an external source, you would use external there. You can modify your transmit and receive gains, and then moving down to the cell config is where we set the band, we set the downlink ARFSN. So that's not actually going to be the SSB ARFSN, that's going to be the carrier ARFSN. And then based on whatever configuration you're using, it will set the SSB appropriately. You can change your channel bandwidth. I'm using 10 right now. Your subcarrier spacing is 15 kilohertz in this case, and then this is where your PLMN needs to match what your AMF is configured for and your tracking area code, so TAC. So I've got 00101 and TAC 77. If you are using SRS UE, then you're going to want to modify. Oh, you can also change your PCI here, your physical cell ID. But if you're running SRS UE, you're going to need to add these lines here. So just be aware of that. You need to explicitly define these for SRS UE to work. Again, SRS UE for 5G only works on band 3, so utilizing this configuration is optimal for that. If we scroll down, we can see our where our GNodeB log is going to be saved to and the log level. You can go in and change the logging level for each layer that's going to be collected. And then we can go down to our PCAP, so it's going to collect PCAPs on the GNodeB for whatever we specify. Right now it's the MAC and NGAP interfaces are going to be collected on. The MAC includes RRC messages, and the NGAP has all the SCTP and NAS messages between the user equipment, the GNodeB, and the 5G core. And then you can go in and enable the E1 and F1 interfaces as well for connections between the GNodeB CU and DU if you'd like to analyze those as well, and also the GTPU interface for when you're doing data traffic analysis and how it looks at the GNodeB. So now we're going to get into running the 5G network, but there's a few things that we need to cover before that. So I've got my SIM card in my commercial UE. If it's out of airplane mode, I can go to my network settings, SIM and network. I'm going to want to make sure that voice over LTE is turned off, data is turned on, roaming's turned on. If some phones might have 5G standalone that needs to be turned on somewhere in here as well, but you might need to turn that on. We can go and check my APN. So whatever the name is, the APN needs to match there, the country code and network code need to match, and then the IPv4 protocols are all set there as well. And if we look at IMS, it's going to be a lot of the same. So we see that there. So our phone is pretty much set to go right now. So the first thing I like to do, since Open5GS doesn't have PCAP logging enabled within the program, I just run a TCP dump. I run it on any interface. I know it's probably going to be a lot of information, but obviously I can just use Wireshark filters to find what I'm actually looking for, and then I'm just going to write it to a file named 5gc.pcap, and it's going to start that wherever the directory that I'm in right now. So it's going to be saved to my home directory. So I'm going to go ahead and start that. So it's starting. I need to go into another window so I can let that run, and then I'm going to start my 5G core. Just confirm everything's up and running. Looks good there. So some things that we can do with the 5G core network that are useful. Obviously we use the PSOX grep Open5GS to check everything's running. I also just like to run to check your configuration, and it's useful with troubleshooting sometimes, just seeing what addresses and ports are being used. So I like to use, we'll just type it out, netstat/tulpn and then grep Open5GS. So that'll give us a list of all of the different network functions and the ports that they are utilizing. So we see 2152, 8805, that's your PFCP, I believe. Actually, let's go and look here. So we've got obviously 9999s for our web UI, 27017s for MongoDB. 8805 is that PFCP connection between the SMF and the UPF, and then the 2152 is your GTPU between the UPF, the SMF, and then we've got 38412, which is going to be the SCTP connection between the AMF and the GNodeB. And then we've got all these 7777s, which is going to be what all the network interfaces, network functions use to interface with one another over the service-based interface. And again, you will notice that the UPF is not part of that, so it is not there. We can go just look again. You can see all the different network function process services that are associated there as well. And then let's see what else we can do here. And then I like to just confirm that everything is running properly sometimes. So I can run a tail-f on the amf.yaml to get a live view of what's going on with the AMF. Oh, that's actually not supposed to be amf.yaml, it's supposed to be amf.log. So excuse me there. But so now that's running. So now we've got two windows, one doing a TCP dump, one showing us our log of our AMF. So I've also got my USRP attached to the laptop now. So I like to just verify that the USRP has GPS connect. So user lib UHD utils. I'm going to go look in here, and then I'm going to use this query GPSDO sensors script. So the first time this goes, it's going to load the firmware image. So we downloaded those earlier, but so every time you disconnect it physically and then reconnect, it's going to always reload that FPGA image, so it might take a little bit longer. But we see now it's trying to align the time. So right now, I'm not getting any GPS from the GPSDO, so you can see that it's trying and it's giving up. And then we can see, the UHD time versus the PC time down there. Sometimes you just need to kind of kickstart it a couple times and let it run and get it to connect. Sometimes, it's just the environment that I'm in. So generally you should see, something similar to, where are we? Right here. So it should say GPS and UHD device are time aligned, and you should see everything kind of in sync down here. We'll go ahead and try one more time. Again, it's important, but for the sake of just running you through all of this right now. So there we go. So GPS and UHD devices are time aligned, and now everything is looking good there. So from here, I'm going to go to my SRS RAN project, configs, and then I'm going to run the GNodeB. So we should be able to do sudo GNodeB tac-c and then just point it to the config file we want to use, and then it should start running there. So we're going to see it kind of set up, and then once it starts broadcasting, so something's going on here, right? So we have some sensor issues. So generally, if I just come in here, I will, for whatever reason, I'll just comment out one of these and then go to start. So now we are broadcasting. So we see cell PCI1, bandwidth 10 megahertz, our ARFSIN, and then it gives us our SSB ARFSIN and frequencies for uplink and downlink. So we are running right now. If I go back to my AMF log, I can see the connection to the GNodeB has been accepted. That's the address I assigned to the GNodeB. So everything's looking good there. So if we just scroll down a little bit further, now I basically just need to connect my user equipment to the network, which, I have to confer with my handset and see what we can get. So it looks like something happened. It looks like the connection with the GNodeB stopped for some reason. So again, always helpful to have your logs up and running so there was no other indication of that happening. So we'll go ahead and restart this. We should be able to go back, see everything's attached again. Again, going to go and look for my network on my phone. So it looks like my phone actually got rejected. And that's probably something happened up here to where everything kind of started to go awry. So we'll come back and troubleshoot that. So I was able to diagnose what was going on. So simply, if I bring up my 5G Core PCAP, I was seeing, and I just set it to OpenAPI and NGAP, I can kind of correlate different events that are happening and then what's going on. So I see that the registration request and identity request, so the registration request comes into the core network and it sends identity request. But if I look over here, I can tell that only a couple, there's only a few connections that are happening when there should be more. So I see, the network repository function is being communicated with, the SCP is being communicated with, the AMF is sending this, but there should be more communication going on with different network functions here, right? So I went to my NRF configuration file within my Open5GS, and I noticed that my PLMN ID was not set correctly. It was the default PLMN that came with Open5GS. So I needed to change that to 00101. So again, something to be aware of there, right? So if I go out of here and I pretty much start this whole thing over, right? So I'm going to start my TCP dump again. I'm going to come over here and I'm going to start my 5G core. Confirm that everything's up, and once again I'm going to start my GNodeB. I'm going to also come back here, do my sudo tail, and look at my AMF. So we're all connected, we're up and running the GNodeB. I'm going to again take my phone out of airplane mode. See some stuff going on, and since the core network already has the context for this phone, I just deregistered, or attempted to send a deregistration message, but nothing went across. Going to try this one more time. There we go. So my phone is now connected to the base station. I should have service. So I'm just requesting it. I just went to Amazon on my handset. If I go and I tail my SMF log. Yeah, so we see a bunch of stuff going on in here with the SMF. Obviously seeing some more issues in here, but for the most part, I'm getting service on my handset right now. So I'll show you just what that looks like from the phone's perspective. So again, I'm on 5G network here. If I just go around clicking to different websites, I'm able to do that. Let's just go to radioconcepts.io. And there we are. So again, this is using the open source 5G network and how it's working. And also kind of helps enforce the usage of your log files and using that to troubleshoot different problems that you might be running into.